All right, so we did a problem like this already. We're gonna do another one because you guys didn't get a chance to practice. You just got a chance to watch. So I'm gonna do another one so you can watch again, and then but this time you'll have a chance to practice. Okay. So here we go. We have a particle moving along the x-axis, and we have its velocity given there. Now that's an ugly equation, right? Which means we're using calculators, right? So. And then they also tell us here that x of 0 equals -5.
That's our initial condition.
That's our position, right? When t equals 0, the position is -5. That's where it's located on the x-axis, okay? So now this question is asking us, when is the object furthest to the right? So it's asking when it's furthest. So that would indicate that we're looking for a max, right?
Yes.
So when we're looking for a max, then what we're going to do is we're going to do the candidates test. Okay? So you need that back?
Yeah. Yes, please. Come on, man.
Okay. So we're going to do the candidates test. This is just notes. You don't have to necessarily write these when you're solving a problem. Yes, sir?
I thought you can't use the candidates test if the... Oh, never mind. Never mind. Never mind. I see. And we can use the candidates test because it's continuous.
So that's a good point. Yeah, technically the candidates test only applies if it's continuous. Now, sine is continuous, and a polynomial is continuous. It's a good question. Since they're, let's just go ahead and solve it. We'll ignore that for now. But I'm wondering, that might actually be negative. Oh, that's not factorable on the bottom there, is it? Doesn't look like it. So since it's not factorable, I don't know what the roots are. But technically, if there was anywhere on this interval that was between, if the roots down here were on this interval, that would be bad because then you would have a point of discontinuity.
And then you could
yeah, then technically you wouldn't be using the candidates test. That's a good observation.
Yeah,
so we have to do the Mr. Bailey, this answer is whack.
Let me. I've already worked it out. I didn't get too whack of an answer, so I'm gonna try it. Maybe it comes out whack. We'll see. All right. So I like to start with the candidates test like this. Well, what am I gonna call this column, you guys?
T,
right? What am I gonna call this column?
X of T.
Doesn't matter if it's any X of T. Like you say F of T, or does it have to be?
You should say X because in the beginning it said X of 0 equals -5.
Oh,
so that's the name of your
why it
function.
would be X.
Yeah. So now my endpoints are 0 and 4, right? I'm going to label those as endpoints. But we also got to find critical values. Critical values occur where x prime equals 0. Now, what's another expression for x prime?
X. Big X.
V of t, it's the velocity. Okay? So, in other words, if I want to know where x prime of t equals 0, then I need to find out where v of t is equal to 0. And that's where we get to use our calculator. So, here we go.
How come we wouldn't find where it's going to find too?
Good question. Thank you for asking that. We actually probably should do that.
Because there's a bottom. And we use the bottom to find
You're
out.
right.
Put it in the calculator.
You're right. Let's go ahead and do this for now.
Alright.
So y equals, we're going to go ahead and put in our function here. What is it?
10 sine
10 sine,
0.4
okay.
x squared.
And you're right. Yeah, we should put that all in parentheses, right? I guess you kind of don't really need to, but I'm not going to go into y right now. I'll just go ahead and do it just to be safe. And then divided by, and then in parentheses, the bottom was x squared minus x plus 3. Good? All right. So let's go ahead and look at our graph here. And I want to find out where my derivative equals 0 on the interval from 0 to 4. Now, all I care about is the interval 0 to 4, right? And I can also see here that the y value kind of reaches its max around 3. So I'm going to set my window here. I'm going to go from like maybe -1. I don't like to start necessarily right where they tell us to start because it's hard to see the graph at the edges. So I'm going to go a little further back. And then instead of stopping at 4, I'll stop at 5. And as for the y values, we don't need to go all the way up to 10. I saw the highest value was about 4-ish.
So we go 5, maybe.
Well, actually, it was like 3-ish, so I'm going to go up to 4. But yeah. And I don't know. I'll just do the opposite for the negative. So I'll say -4. All right. So now let's take a look at our graph. Get a little bit better of a picture. Uh-huh.
My graph looks like it had a spasm.
So that would be a graphing issue or a typing issue. So
Oh, you put the bottom in parentheses.
yes. Okay. All right. So I see 2 places where my derivative is equal to 0. Trying to I see it's equal to 0 like right about here.
Yeah.
Right?
It's like
And this one's hard to tell. I don't know if this is before 4, at 4, or maybe a little after 4, so I'm going to check it just in case. So let's go ahead and check both of those. So here we go. You guys remember how to do it? Find where it touches the x-axis. What do I push?
main
Math?
number.
No, wait, graph. We push
Second.
calc,
0.
0. And then we pick a point to the left and a point to the right of the root I'm interested in.
So let's go under.
And then enter. So there's one of my critical values. I'm going to store that under alpha A, okay? So to store it, you push enter first, and then you're going to push store, and then you're going to click alpha, and then A is the button right underneath of it. Click enter again, and you should see that number. So now A is stored as that value. It's the green button. All right, back to the graph. Now I'm going to repeat that process over here. If it's less than 4, I'm going to use it. If it's equal to 4 or greater than 4, I don't care because we're only looking at the interval from 0 to 4. So here we go. Let's go ahead and do that. We're going to go to second, calc, 0, pick a point to the left. And a point to the right of the 0. And it's less. Really close to 4. So it's 3.963.
Circle those stuff inside. Purple. Is that yours?
Yeah, with the software. It's not in the calculator.
I love asking. I was like, how do you do that?
That would be cool to do it. Yes.
Why does the Y say that?
Why does the y value say what? So that, yeah, why? Because our calculator it operates on an approximation basis. It doesn't figure things out the way that we do. It zeroes in on things, and so it's an approximation. This number is so small, it's 0.
This is really fun. So
Yeah.
I'm kind of like behind real fast. So when after we hit trace and we hit like calc intersect,
You second,
then you hit
trace,
and then you already hit
2, 0, not
step
intersect.
5.
Okay, so now I'm going to store that one too under alpha B this time. So we're going to call that alpha Oh, I forgot to store. I might have lost it. Let me try again here. So I'm going to push store. The last answer, alpha B. Yeah, we're good. All right, so I've got those values stored. All right, so let's go back to our thing here. I've got some critical values. What was my first one? You guys can see it on your home screen there. It was like 2.803. 2.803. And what was the other one?
3.962.
Okay. And now Nick had brought up we need to find out where it's undefined as well. Now we could use the quadratic formula, but I don't really want to do that. So what I'm going to do is I'm going to first of all I'm gonna get rid of this equation here. So I'm gonna scroll over here. You guys see how that line's blinking? I'm gonna push that until it's gone. Not gone, but I'll show you what I mean. It's just a ball. Okay? And what that means is when I graph it, it's just gonna show a ball tracing the path, but it's not gonna leave a line, so it won't be on my picture anymore. And I just don't want it in my way. It's confusing. So what I'm going to do now is I want to find out where does the bottom equal 0. So the way I'm going to do that is the same way I just did the other one. I'm going to type this equation in. I'm going to see where that equals 0. Okay? Now you could also just use a quadratic formula. But I don't know. I've got a calculator, so I'm going to use it. So x squared minus x plus 3. Okay. And then we're going to graph that now. So see the ball moving along? It's not going to leave a line. It's just showing us where the other function's at. And then it's going to graph the other one, the y2. And that one I do care about. Oh, it doesn't look like it touches the x-axis at all. So we're good. There's no undefined values, so we don't have to worry about any critical values for that one. All right, so I'm going to come back, and since I don't need that, I'm just going to delete it. You don't have to. You just don't have to use it. If you don't want it, I'm going to delete it. All right, so anyway, back to our board here. So we've got this, and now I want to figure out what the x values are, because remember, my goal here is I want to find the point furthest to the right. So let's review what we've done so far. A lot of stuff has happened. Don't want to lose you. So find the point furthest to the left. We did the candidates test, which means we need to test the endpoints and the critical values. That is where the derivative of x, in other words, v, equals 0, and that's why we just found those roots, which are my critical values. Now we're going to plug them in and see which one actually gives us the x value that's furthest to the right. Okay? Now we get to do some other math. How do we find a formula for x? Well, x is equal to your starting x, right, plus the net change from 0 to 4 of your function v of t. Okay? Now we'll just put what x of 0 is now. What is it? And that's what we're going to type into our calculator. But actually, you know what? I'm going to change that 4 to a what? A t, because I'm going to be testing a lot of different numbers. I'm going to plug in 0, this, and this. This one we already know. When t is 0, what's x of t? Negative 5. The other ones we actually have to calculate. So here's what I'm going to do. I'm going to divide up the work a little bit. I'm going to let you guys do this. Can you guys, you two rows here, can you guys do the alpha A, please? And when you type this in, click alpha A for this spot. You could type in 2.803, but it's better to use alpha A. Can I have you guys do alpha B for me? All right. And then can I have you guys over here do 4 for me, please? Yeah, what's up, Will? Sure. And so there's our outcomes. So which one's furthest to the right?
2.374. 1.709.
Right, yeah. All right. So now look at the question. Look at the question. What's the question, guys? What is the question? True, but what's the question? There's a key word there. When. So what's the answer?
Oh,
2.803. The answer is not this. That is the coordinate that's farthest to right, but the question is when is it over there? And the answer is 2.803. So there's our answer. T equals 2.803, and it didn't give us units, so we're not putting units. Okay? All right, so I'm going to let you guys do it from beginning to end on your own now. But this is a very common question, and as I started assigning you guys FRQs, you'll see this at least half of the time. Now, it took a long time because I'm explaining things. Hopefully, you guys will kind of find after a while it's just as easy as pushing a few keys after a while. But the concept's there, yeah.
The reason why it's T equals 2.803 because that's we want it was closest to the right.
That's right. No pun intended. All right, so your turn to try one. I'm going to give you this one. I'm going to give you a velocity of v equals e to the negative t sine of t, ugly equation. I'm going to tell you that x of 4 is equal to 2. And then I'm going to ask you to find the point where it's furthest to the left on this interval here, 3 to 8. Just so you guys know, now this question I got out of your FRQ book is one of your actual FRQs, so is the other one. But this one, I'm pretty sure they actually expect you to do it by hand. I'm not going to ask you to do it by hand. I'm just going to have you guys use your calculators because that's what I want you to practice now. But yeah, you would use product rule. There you go. There you go. There you go. All right. Enough said. All right. So I meant to put from 4 to 8 here. All right. So here we go. Ready? Candidates test. So we're going from 4 to 8, and it was really hard to find that 0, but it existed, and we found it was at what?
6.283.
And you know what that is? I'm pretty sure that's 2 pi.
Is it really?
Yeah. Good. Okay, I'll get you, Paul. In honor of Pi Day.
It's also 0 at pi.
All right. But you're right. It is 0 at pi, but we only care about the interval from 4 to 8. So we're not going to use that one. All right. So at this point, we need to use our formula. Your formula should have looked like this to find any given point. Okay, guys, take a look up here. Did you guys put a 4 for your lower limit?
Yes, sir. I got it.
That's important.
And I got the answer.
It's common to want to put a 0 there, but it's 4.
It's gonna be.
Okay, so let's go ahead and find out what we got. We already know what this is. It's 2. Yes. Yes.
So for the xt function right there,
Yeah.
can should I change the variable on top of the 4 to something else than the what's the variable inside the actual option? Because you're using t in 2 different separate functions. Are you supposed to change it?
That's a good question. I don't have an answer for you right now. So for now, let's not worry about it.
I
But
mean, I did change it so that way.
I know what you mean. Yeah. I think that's a good point. But for now, let's go do this. So now, what did we get for 6.283, guys, by plugging in it? What is it?
Just be there. Okay.
And then how about 8?
No, it's 1.9. What? 6.
8, 6?
Yeah. Wait, hold on. What?
And how about the 8?
1.987.
And so which one's furthest to the left?
6.283.
2 pi.
2 pi.
2
Hold up,
pi.
hold up. There's something wrong there.
2 pi.
Oh, you're right. You're right. You're right. Okay.
Yeah, come on, brother. Hold on.
There you go. You're right. So at t equals
2 pi.
6.283 or 2 pi. Yeah. All right.
I put coaching in.
So there you guys go. That's one thing. Let's move on to another one. Here we go. Example 2. I'm going to ask a bunch of questions about this particular problem. Here we go. The first question is, when is the particle moving left? And when is it moving right? So let's go ahead and copy that down real quick.
That's a nice function.
It is, and we are going to be doing it by hand. Some of it, anyway. Okay. All right. Guys, can you tell me what this function is? What does this represent? That's a position function. Now, it's asking me when is the particle moving left and right? What function tells you which direction it's going?
Velocity.
Velocity, which is the derivative of the position function. So, x prime of t, yeah, Tom?
If the derivative of a position function to be a velocity, would acceleration be the derivative of displacement?
No, acceleration is derivative of velocity. All right, so now I want to find out when it's moving left and when it's moving right. So whenever velocity is negative, it's moving left. When velocity is positive, it's moving right. So what I'm going to do is I'm going to find where it equals 0, and then I'm going to do test points. The number line. Here we go. 0 is equal to 3x squared minus 12x. Now I am going to do this by hand. Could we do this on the calculator?
Yeah.
We could graph that and find where it touches the x-axis, but I'm going to do it by hand because honestly I think that's a lot easier for this one. I'm going to go ahead and take out a 3x here, and that means x is going to be where?
0 and 4.
0 and 4. All right, so now I'm going to do a number line test. I'm going to write it over here.
Oh, no, what that is.
And this is an open interval. It's 0 and 4.
Oh, I put 3.
Point for all.
Point for all people. Okay.
Mr. Bailey.
I still owe Paul a point.
Makes the wrong there for everybody in the class.
All right. Test points. Ready? So let's do. Let's find out what x prime of -1 is. If I plug in a -1 here and here, what do am I going to get a positive or a negative outcome?
Negative.
Positive.
Positive.
If I plug in x prime of 1 here, what will I get? And how about x prime of 5?
Positive.
Right. Okay, so we have an answer to our question then. The particle is moving to the right anytime the velocity is positive. So that would be from -infinity up to 0, as well as from 4 to infinity. It's moving left in between. So that would be from 0 to 4. Okay. Now, make sure you guys leave a little space underneath of this, because I'm going to draw another number line under there in a minute, and we need them to be kind of next to each other to compare them. So there's that. My next question. My next question is, when is it speeding up and slowing down?
Acceleration.
Yes, very good.
So the second derivative, right?
Yep. Okay, so what we learned yesterday, I'm glad to hear some of you guys are like already on step 2 of that thought process. That's pretty cool. To know when an object is speeding up or slowing down, you need to look at 2 things. You need to look at velocity and acceleration. When their signs match, it's speeding up. When they're opposites, it's slowing down. So now I'm going to find the acceleration. So x double prime of t is equal to what? Now I'm going to set that equal to 0 and solve for x.
X equals 2.
X is 2.
That's right. Once again, I'm going to do another number line test with this, okay? I'm going to do another number line test.
2 would be negative positive.
So here we go. Number line here. Now where is 2? It's going to be in here somewhere. So I want my number lines to match. So I'm going to put 2 right in the middle there, like that. But it's a separate number line, but I still want the numbers to be about in the same spots, okay? All right, so we really just have 2 regions to test. So over here I'm going to do x double prime of 0, sure. And over here I'll do x double prime of what? 3, why not? All right, so what if I plug 0 into this, what would I get? And if I plug 3 into this, what would I get? A positive. Now we need to find the regions where they have the same signs. That's when it's speeding up. When they have opposite signs, they're slowing down. So, here we go.
From 0 to 2, it's speeding up. From 0 to 2, it's slowing down.
All right, here we go. So I'm going to draw like a line here between each interval, just so you guys can see it. Put pluses in here.
Sorry.
Do you guys see I just put signs everywhere, kind of included all the intervals there. All right, what's happening from infinity up to 0?
Slow down.
What's happening from 0 up to 2? Speeding up. How about from 2 to 4?
Slowing down.
Oh. And lastly, 4 to infinity.
Speeding up.
Every time they're the same exact sign, they're speeding up. They're opposite signs, they're slowing down.
Yeah.
Is that what you say that?
And I think that's the end of that question. That's it. So I want you guys to practice some, but that's the end of that question.
This is like Unit 5.
It is Unit 5. This is actually not Unit 6 at all, but it's very relevant. We're talking about particles. And I'm going to be giving you guys FRQs, and they're going to mix these types of questions with those questions like when is it furthest left, when is it furthest right. So they're mixing Unit 5, so I want to make sure you guys see them all. All right, let's go ahead and throw one at you guys. You're going to be mad at me.
No, you don't.
Okay,
my hand or no? Okay, no, that's easy. It's literally just that.
It's not bad.
Thank you.
Maybe. If you know your unit circle, it shouldn't be too bad. There, that's the instructions. Find where it's going right and left, speeding up, slowing down.